Presenting for us today from Microsoft, we have Ero Celibic, Senior Fast Track Solution Architect, Mustafa Mansour, Software Engineer 2, Peter Fries, Principal Engineering Manager, Anna Skierke, Principal Product Manager. Ero, over to you to get us started.
Thank you, Peter. We will start today's Tech Talk by taking a look into demand planning capabilities and how is demand planning positioned related to other parts of Dynamics supply chain management. We will then have a detailed look into a couple of features which we have built in last couple of months. Then we will dive deep into 3 out-of-the-box AI and forecast models by explaining how they work and how you can decide which one to use for which scenario. We will take a look under the hood of the demand planning app and understand its architecture and which technologies are we using for it. Then we will introduce to you the new licensing model related to the demand planning app, have a look at the short and long-term roadmap, and at the end, we will leave some time for answers to answer your questions. When we think about the planning cycle in Dynamics supply chain management, we distinguish between 3 major parts. First one is demand plan or sales forecast. Demand plan goal is to forecast future sales. When we say future sales, we mean products and services that you sell or enter into sales order or quotation. Second part of it is supply planning, or commonly known as MRP. Third part is supply chain execution, which consists of modules like warehousing management, transportation management, production control, and others. Until now, we did not have proper solution for demand planning, and therefore there could be some confusion with the naming. So, demand planning is not an extension of capabilities from supply planning, like MRP, DDMRP, or planning optimization. Demand planning is sales planning or sales forecast. From now on and going forward, we would like to call these areas with proper name and distinguish more clearly between demand planning and supply planning. Now let's have a look at the demand planning process. Since demand planning is a standalone app, our first step is to import the data. You can select from various sources to import the data, for example, Azure Data Lake, one or multiple F&O instances, or utilize known formats like CSV or Excel files. You can also mix the source of the data as you have your data in. For example, you can import historical demand from F&O instance, import your customer hierarchy from CRM system, and future project sales from an Excel file which is managed by your sales department. Demand planning as a process, we think of it as 5-step approach. The first one, after we have imported the data, is to unify the view on the data. We call this process transfer, where as a result we receive time series or time bucket. These time buckets can be selected in daily, weekly, or monthly time bucket. Based on this transformation, we are then able to run baseline forecast model. Later on in this session, Mustafa will give you more details about the different models that we provide out of the box. The 4th step is actually the step where the most time you will spend in your company, namely reviewing or consensus review. You will analyze, compare, adjust the data that you are having here until you reach a consensus to be able to export this data back. Export of this data can be either again to some third-party tools like Azure Data Lake, or you can import them back into F&O. When you import it back, then they will land into something which you know as item forecast. Coming into F&O, then we can consume them by the supply planning process, where the MRP run can go and create planned orders. The next step of planned order is firm them and execute production, purchase, or transfer orders in the system. At the end result of this execution is that you will have your sales order and shipment of the goods to the customer. Again, this data will be used as input data for the next cycle of demand planning. Demand planning is a repeating cycle. In every period, you will do all these 5 steps one after another. And whatever you are forecasting now for the future, at one point in the future, it will become your input data as historical sales or historical demand. As mentioned, the 4th step of planning, called review, is the most significant one. It's the one where you will spend the most time. This is why we have built different capabilities to make it easy for you to collaborate. First capability here is the option for tracking changes through versioning of time series, similar to the experience that you know from Office applications like Word when multiple people are working on the same document. Second capability is for commenting. You have here 2 flavors. One is commenting on overall, on the whole time series, or commenting on a specific cell. Mostly discussions about planning are happening on a specific value, on a specific cell. Therefore, commenting on cell level is very welcome. Third option to collaborate here is to utilize Teams as a chat client. We have embedded Teams into our experience so that you can invite and collaborate with people who are normally not part of your planning cycle, like plant manager or purchase manager. Another common scenario that we have come across is the topic around planning sales for new items. This is especially the case for seasonal items or when you are introducing follow-up models of an existing item where you don't have any history. Typical strategy here is to take history of a known item and copy it over to the new item. This capability we call phase in and phase out. So not only you have the possibility to take a history of one item and copy it over, but if the new item is not fitting 100% to one item that you have, but is fitting somewhere between 1, 2 or more items, then you can define the source for the new item being more than one data source. Third scenario that we came across is when you are expanding and planning for new stores or new warehouses. The capability of phase-in is not only built on product level, but you can copy on any dimension that you are having. In our example with warehousing, it could be if you are introducing a new warehouse, that you can copy existing warehouse by utilizing some factor to the new warehouse. Here we have a demo where we are going to see an example for phase in and phase out of an item. Here first we will have a look at the setup for phase in, phase out. Here we are phasing in item called budget speaker, and we are phasing out a mid-range speaker. On the rules tab are the different steps that we are defining. Since the phase-in process is not a single element, but it is done in steps, here we can see how the first step is defined. So we define here the start date, the end date, what is the rule type, being it in our case phase-in, what is the uplift, in this case 20%, and from which item we are copying to and applying it to which item. Then we repeat this step multiple times by changing the start and end date as well as factor from 20, 50, 80 to reach 100%. And in the same time, we are phasing out an older item, mid-range speaker, during this process. Now let's have a look at the result of this action. Here we have a time series where we are displaying our 2 items. Here you can see the green graph is showing the new item that we are introducing, where in the first 2 months we are having 20%, then 50, 80, until we reach 100%. The purple one is showing the item that we are phasing out. Down in the table, you can see from January on, when we are finishing phasing out, this item, the old item, will be in the time series with 0 value. We have built demand planning app to scale based on your need. Peter will give a detailed architectural overview later in these sessions. On the right side, here you can see a snapshot of the different import sources that you can select, which is based on the Power Query library. Another option to extend demand planning app is by doing so for tables and columns without any need of developing a code, because everything is done from inside the UI. Another important feature of the demand planning app is the capability to slice and dice on the fly based on the dimension that you're having here. You can aggregate and disaggregate in real time without the need of predefining views, time series on different aggregation level. Very common ask in the sales forecast area is the possibility to limit access of different salespeople to see and edit only items which are in their region, for example. This capability we call row-level security. Here I have a demo about row-level security where we will be defining access for another user to see and work only for items for one specific warehouse. Let's check out the setup for this one. So this setup we call Store 1 Manager. Then under condition, we define one or more conditions that are applying here. In this case, it is the warehouse location name equal to Store 1 US. Then on the user, we define one or more user that we want to apply this condition. And here we can define what this user can do with this data, edit or view. If we now look at the result on a specific time series, then here we have a view of a manager which does not have any limitation. He has access to all the data, all the dimension values, so he sees values and data for Store 1, Store 3, Store 4, etc. Let's have a look at the other user, Jamie, by opening the same time series and comparing the results. In his case, he sees only the data which we have defined in the rule, namely only the warehouse location being Store 1. Without doing any additional filtering on predefining any time series, by just defining the rules, we can limit the data that this person can see. Now Anders will tell you more about our investments into Copilot areas.
Yes, thanks, Errol, for that. Yes, so one of the things that we're really focusing on is to make analytics available for the demand planners. So we have today the chart, which gives a nice correlation on the data for the time series. And we also have the grid where we can do different kind of formatting and so on to help the user see if there's anything that is of specific urgent to actually correct or be alerted to in the forecast on the detail level on the different planning dimensions. But by using Copilot and introducing Copilot, we can actually build an active search based on different capabilities and different metrics that again can traverse massive amount of data and at the same time come up with a very user-friendly text written, potentially also with table and graph soon, so we can present a specific ask on the massive data in a very condensed way, which is easy for the user to actually understand and thereby take action on. And for now, we are using Copilot. It's in it's a public preview. And right now we have one question, which will look for shifts between two consecutive periods. So let's run the video, and then I will also talk about what is coming next here. So here, the way we have done it is that on the graph itself, every point on the graph, on all the different kind of graphs, so this could be a forecast, it could also be a financial impact assessment of the plan graph that we are looking at. And when you click any dot here, then you can look at two consecutive periods, and the system will actually give you the shift in percentages between the two periods and also in the quantity. And thereby you will be giving the biggest shifts between these two consecutive periods. And if I had 3 dimensions, it assists all 3 dimensions. It assists the first dimension alone as a whole, which could be a region. Then it goes through my product and then potentially my store. And it means also I can get if there's been a significant shift in a region, I can get a significant shift in a product. I can get a specific shift available on a product in a region. And again, if I then combine it with the store, I can also get if a certain store has a specific shift in either positive and negative. But I can also see if a certain product in a specific store actually has a problem, meaning a shift. And this could be downwards and upwards. So this is a way to traverse a massive set of data to very easily give the user the right context of what he should actually investigate. We will come with more pre-prompt questions because right now we have 2 pre-prompt questions. We compare a shift between 2 consecutive periods or 2 consecutive years, meaning year-over-year comparison. We are coming out with more pre-prompt questions like trend analysis, anomalies, and forecast accuracy as well. So these are the ones that we are working on right now. And that will give the user, the planners and the managers, again, a very much more intuitive and interactive analytics on top of the plan. And hopefully it will help them also make sure that they're doing the best edits to the plan. So this is some of the things that we are working very hard to do with using Copilot. Of course, our aspiration is that once we are getting better, that we can actually suggest changes and thereby also potentially going forward, let the system do the changes. Thank you. I will hand it over to you, Mustafa.
Hello, everyone. My name is Mustafa, and today we will dive deep at the existing outlier removal algorithms in the demand planning app, forecasting models, how they work, and finally, when to use what. So with that being said, let's dive into it. First, the outlier removal. The 2 current methods which you can use for pre-processing and removal of anomalies and outliers from your input time series are STL and IQR. STL stands for Seasonal Trend Decomposition Using LOWS. We will talk about what LOWS is. And IQR is an acronym for Interquartile Range. Essentially, STL decomposes the time series into 3 components: trend, seasonality, and residuals. A residual is basically the raw time series after removing trend and seasonality from. If we take a look at the graph here, we can see the residuals plotted as scattered points. STL tries to smooth the outlier using LOWS. LOWS is simply a generalization of the moving average and polynomial regression. It tries to fit a line through the scattered dots, thus smooths the residuals during this process. After calculating the mean and standard deviation of the residual, it uses them to get rid of the outliers and mitigate anomalies. Lastly, STL adds again the seasonality and the trend to the newly smoothed residual. You can proceed to the next step. The demand planning app, you have the flexibility to set the seasonality period of your time series, and STL will adapt to this change. The other outlier removal method that you can use is IQR. In the context of the interquartile range, multipliers are used to identify outliers by creating boundaries. When choosing the IQR as your outlier removal method, you need to configure the multiplier value. A high multiplier increases the range within which data points are considered non-outliers. This results in having a more lenient definition of your boundaries and include more points. Thus, the IQR method will be less sensitive to variations in the time series. A low multiplier, on the other hand, decreases the range within which data points are considered non-outliers. That means you get stricter boundaries and more data points will get removed and discarded. To calculate IQR, we first need to find Q1 and Q3. The Q1 is the 25th percentile and Q3 is the 75th percentile of the data. And here, by data, we mean the quantity sold in your historical sales data. Then the range is calculated as shown in the slide, and anything that lies outside of the lower and upper bounds is considered an outlier and it gets removed. So which method suits your business case? Well, if we took a look at the IQR, it's highly suitable for general purpose outlier detection in any type of data set. It's ideal for time series data without strong seasonal or trend components. As IQR is purely statistical, it is faster. And an example of when to use IQR is if you want to detect outliers in financial transactions or sensors readings. On the other hand, STL is best used for time series data with clear seasonal and trend patterns. It is ideal for applications where distinguishing between normal seasonal variations and true anomalies is crucial. Example of when STL is suitable is if you want to analyze sales data with seasonal spikes, or temperature data, or website traffic. Next, we will talk about the out-of-the-box forecasting models which exist today in the app. We have ARIMA, ETS, Profit, and then we have a best fit algorithm, which we will talk about later. Let's start with the simplest model, ETS. The core idea of ETS is forecasting future data points by applying varying weights to different observations where recent data points carry more weight than the older ones. As for more advanced ETS, it decomposes the time series into trend, seasonality, and error components. The error component here is the noise and fluctuations in your time series. It uses the seasonal period parameters set by the user as the seasonal index. Afterwards, it estimates the trend in the upcoming horizon and tries multiple values to see what fits the model. Finally, the model forecasts the error and then combines it again with the estimated trend and seasonality components. The app figures out which flavor of ETS is most suitable for the time series and applies it accordingly. If you're curious about the formula of ETS, we have included it in the slide. All of this is abstracted from you inside our app so that you focus more on planning and worry less about how the algorithms work. Next on our list is a RIMA model, which stands for Auto-Regressive Integrated Moving Average. Now that was a lot of words, so let's break it down. A RIMA is suited for stationary data. Stationary data is data with constant mean, constant standard deviation, and no seasonality. The I in ARIMA stands for integrated, and sometimes it is called differencing. And differencing is a step that the ARIMA model takes if the time series is non-stationary, and then it morphs it into stationary data before it forecasts. The AR, or autoregressive, and MA, or moving average, serve distinct but complementary roles in modeling the time series data. The AR component is part of the model that regresses the time series on its own previous values. It captures the influence of past values on the current one. As for the MA component, it accounts for past forecast errors and improves the model's accuracy by smoothing out the noise. ARIMA basically combines AR and MA after differencing the data. The final prediction is a combination of the influence of past values and the adjustments from past errors. Of course, if you're curious about the math behind the model, you can check it out. Finally, the relatively new model, Profit. Profit decomposes the model into three components as shown: seasonality, trend, and this time, holidays. You don't need to worry about placing an outlier step before using it, as it auto-detects outliers and cleverly adjusts its weights when fitting the model. First, it handles changes in trends by detecting change points where the trend changes its direction or rate of growth. Then, it auto-detects seasonality of the time series using the one provided by the user as a hint and accounts for noise in the data. Finally, it combines holidays components along with the trend, seasonality, and error. There are diverse business cases. So which model to pick? ETS shines if your business case is simple and the data has various patterns like linear or exponential trends. As for ARIMA, it is recommended if the time series has non-significant seasonality or its seasonality can be managed through differencing. On the other hand, Profit performs best with seasonal data and accounts for holidays during forecasting, doesn't need much pre-processing. We realize that your business case will vary, and when having big data, it contains literally thousands of time series inside of it. Each is embedded with different trait, characteristic, and its own story. And every model is suited for different scenarios. So it will take time and effort to test all of this and cross-validate. Well, worry no more, because that's exactly why we have provided best fit. When choosing best fit, the forecast job run will try every forecast algorithm we have mentioned on every dimension in the input time series. It will then let them compete by comparing which has the lowest mean absolute percentage score, and it will pick the winner of that time series. This will save you setting up and comparing multiple runs with just one go. That's it for the forecasting algorithms, and now hand it over to Peter, who will talk to you about the architecture.
Thank you. So as Eero mentioned on one of the earlier slides, we support a number of inputs into the demand planning application. These inputs consist of Excel, CSV files. We support Azure Data Lake and third-party system. And all of these things are managed through Power Query, where the Dynamics 365 SCM is a native connector that we have directly in demand planning. The same on the export side. We have Dynamics 365 as an integrated part, and we have CSV files so that you can integrate with other systems, or you can do post-processing depending on your needs before you import that back into SCM to further process and do the supply chain planning inside of that application. So to look a little bit more into how this actually works together, we're going to take more insights into the platform and into the demand planning. So the demand planning application is installed as a Power App on Dataverse, and we rely on the platform with a number of components to leverage all the needs that we have for the application. So the integration services here consist of Power Query and the integrated connector for SCM. When that runs, that places the output of that process into Managed Data Lake, and then we consume that into our volume data store. So could I ask you to go back? Thank you. So when we store data for the demand planning, we mainly store it in two different stores. One is the Dataverse entities, where we store a lot of the metadata and the system data for the system. But when you look at time series or you look at volume data in the tables, that is all stored in a separate store, volume data for higher performance. That is what gives some of the flexibility in the UI that we see for the time series when we navigate and we update. But every time we process any of these data, for example, when we do a forecast, that is represented by the forecast execution on the right side, to get the data to the actual algorithms that was just presented, we get the data out of the storage, we place it in Managed Data Lake, where it is then consumed by the forecast engine, and again, it produces that output and places it back into Managed Data Lake, where we then consume it into our data store for further analysis and the UI. So this also shows how we are actually leveraging Managed Data Lake for various periods throughout the process for containing the data between the system. So this is a very integral part of moving data around the system for processing. When we look at the right-hand side for the custom Azure ML integration, that is a resource that is provisioned in the customer's own subscription. And also when you provision an Azure ML instance, it also needs a storage account, an Azure storage account for the data going in and out of the managed Azure or for the Azure ML. It is the same thing that we do on both sides here. when we call from the demand planning application and we need to execute anything within Azure ML, first we place the data in the storage. Azure ML consumes it, does the processing, gets it back into the data storage, and we consume it back into our volume data store. So this is the way that the data is being processed on both sides. And as I mentioned before, when the data is available, it's been signed off on all parties, then you can export it back into CSV file or into supply chain management. Now we'll take a little bit of a look on the application lifecycle management. So from an installation point of view, you can install the application from a Power Portal Admin Center or PPAC. It comes default installed on SCM environments with dual write. So that means that when you have your instances, it will already be pre-installed. However, there is no dependency on the actual dual write environment. You can install it on any Dataverse environment. And as it was also represented before, given the connectors comes from the demand planning application itself, you can connect one instance of demand planning to multiple SCM instances, depending on your need. This also enables you to have a test environment with demand planning. And if you need the latest sales data to do some tests, you can always connect to the production SCM instance, get the data to make sure you have everything fresh from the DB there. Regarding updates are available every month. It is visible on the doc site. We will share a link where we will update on a monthly basis what are the new things in the version that is coming out. Please bear in mind that when we do an update, the rollout takes approximately 2 to 3 weeks to roll out across all the different geographies that we support. After the update is released to all regions or all geographies, it is force updated approximately 2 weeks after it has rolled out globally. This is to ensure that any fixes that we do, any security things that we do, any new features that brings more value to the product gets into your hands on a regular cadence, and it also enables us to give the best performance and the best experience for the product. Regarding lifecycle events, so we support a number of these. We support enable and disable organizations, we support copy organizations, and we support delete organizations. So this means that if you have an instance of demand planning and you need to try out things, you can actually copy that organization and you can do tests, and when you're done with it, you can take it down afterwards. So this was a few words about the application lifecycle management.
Thank you, Peter, for that. Yes, I'll talk about licensing because the demand planning application will be under a new SKU license that we have shipped, which is called Dynamics 365 Supply Chain Management Premium. And the reason why it's called Supply Chain Management Premium is that this SKU may be used for other apps in the future as well. And my Supply Chain Management Premium and the whole concept of premium SKU may not be new because the finance of Dynamics 365 Finance and Finance Premium is all the same pattern we are following here. And the list price is $300 per user per month for using these premium SKUs. The entitlement you're getting with the premium SKU is that you, of course, get a license to the standard SCM, plus access to demand planning and full access to demand planning, and you will also get some additional capacity on your Dataverse. I don't want to go in more details on these specifics in detail, but the whole idea is that you're users of the demand planning application, and we have 2 different roles in the demand planning application. We have 3. We have an admin who will be controlling the application, and then we have a manager and a contributor role. The manager will be responsible for setting up the row level security, some of the forecast profiles, or less together with the admin. He will do the forecast profiles and transformations. He can also do some of the worksheets, which are really the reports that you're sharing internally that Errol has shown today. And that require the full SCM Premium. We do have ability for certain users to actually access the app with the normal SCM license that you have today. So if you have a financial person or another manager type who are part of the review process of reaching consensus of your demand plan, these persons can, with the contributor role, access these worksheets, reports. They can also do self-level commenting on them, but they cannot edit any of the data. But they can view the data and comment, and thereby be part of the consensus planning. And they can do that with the normal SCM standard license. They don't need this premium license. It's really only for the persons actively taking part of building your demand plan processes, and also the ones actually actively engaging by making human edits, meaning salespeople or really demand planners, depending on your organization. They will actually be part of the premium SKU and require the premium SKU. So again, it's not everybody accessing the apps that needs the premium SKU. I also want to highlight that at this point of time, the app is not enforcing the license. We have extended the period until 31st of July, where we don't require SCM premium licenses for the users accessing the apps. After 31st of July, you will need to either buy the license, or for partners, we have something called partner sandbox licenses, which will be available. We also have something called a pilot license, which is something that Microsoft sales executives can request promo codes for special customers or certain customers. I don't know all the details, but I know that they can request promo codes and then actually get a promo code for the for the customer. On top of that, we are working on actually putting also a trial, meaning when you go to the SCM Premium, you will be able to do a trial on 30 days. And right now, the plan is to have an extension of another 30 days. And then you on the premium SKU, and then you have to buy the license if you want to use the application going forward. So that was what I wanted to tell you about the licenses. But there will be an additional license for the people who are actively engaging in the demand planning in the organizations. And the next topic is the roadmap. I don't want to commit specifically on, so what you see here is not in any necessary prioritization order. I also just called it short-term and long-term or longer term. I haven't put what short-term means. Some of this, the idea is that we will continue on monthly releases, and we will put in features in each of these monthly releases. So we definitely have a plan what we want to deliver. One of the things that I want to highlight that we're looking at is, of course, as I mentioned earlier, extending the Copilot pre-prompt questions, so you get more analytics capabilities within the application on your forecast, which means you will take better decisions of making your human interactions with the plan. So that's one of the key things we are working on right now. We are also working on something we call context-aware insights with Copilot. You know today that if you've seen the app, there is 3 metrics in the top of the worksheet. We are working on making that actually based on Copilot calculations that are done in the backend, which means that we can actually show a lot of insights. Whenever you open the worksheets, we have already pre-analyzed your data, so you don't have to actually engage and ask for it, but we have actually pre-analyzed it, and we will put the matrix up there in this context-aware banner. This is also something we are working on right now. Then we're working on, one of the key things that we're working on also right now is to extend with additional models in our forecasting, so they can actually handle external signals, like an inflation percentage prediction that you're getting in your country from your statistical office, or it could be a certain industry index. It's also very common. We have customers that they believe they have some sort of a weather signal they want to validate. It could be sun hours per month. It could be how much rain that falls in each month and stuff like that they can use that. And these external signals, it's very easy to implement into the system and today do a visual correlation. But what we will do now is that we will actually be able to input these into the forecast algorithms, and then the forecast algorithm will take them into account, both on the history side, but also on the prediction of these signals, and actually use that in the forecast calculation. And thereby, hopefully, we should actually get a much better and accurate forecast for you. On top of that, we will actually work on explainability of these, because now we need to tell you how each of these signals in the same period, actually for this specific product, actually either uplifted or decreased the demand. So you will actually also learn how these signals, how strong the signals is in actually impacting your forecast of your different products in your certain stores and stuff like that. So these are the insights that we're working on building right now. On top of that, we're looking at introducing time fence, which means that you can actually block your planners for changing. If you have a rolling forecast, some items may have different lead times in different stores or different geos. So saying that the planners in this geo cannot actually change the forecast for 2 months on this item, simply because the lead time of getting the item in stock means that they cannot change it. While in another geo for the same product, your planners can actually change it, and they only block 1 month. So we will work on a more dynamic time fence rules, so you can control what can be changed in your plans. So that's something we're working on. And then you can see the list of these features. One of the things that I also want to highlight here, we would like to work on changing the grid to become a matrix, so you can actually aggregate. So if you have a plan, a 2-year forecast, if you're running a 24-month forecast, that you can, in the second year, can look at quarters rather than months. Or if you're doing daily forecast, you can actually go up to months or weeks and so on. So you can work with that in a pivot grid or matrix grid with the time on top with aggregation. So you decide how to pan it out. But all of these features that we have here are actually something that is coming from customers. We are also working on allocation between dimensions, which means that you can actually forecast on a higher level, which means you can actually introduce a product group. And then you can figure out later on, you can then work on how many products you want to do, how much quantity you want to do in the product group. And when you get closer to it, you can actually expand it to tell you which product is going to be. And later on, you can put it out to which product variants it will be. It could be that if you're doing T-shirts, then you know suddenly which style T-shirt you want to do. Then you have a fixed schema of the coloring and the sizes, because you know from your stores how they are best selling the color and sizes. So instead of doing this manually, we will have a fast predefined allocation basis rule that you can apply, and then the system will do the allocation for it. But this means you can actually start plan on a higher level and then let the system disaggregate it later on by doing allocations. On the longer term, I just want to also explain here that we are looking at doing supply and demand balancing, and thereby also doing inventory prediction. The whole idea is that, again, we want to put the supply data, meaning the planned forecast, the planned purchase orders, the planned production orders and transport orders into the demand planning application, because we have a nice way of viewing the data on time series views. And then when you also bring in your inventory on hand, we can actually do an inventory prediction going forward. And you can actually see if there's any stock outs with the current situation and the current supply that are coming in. And if you then change the demand, you will also see, can I even change the demand in this location? Because current supply is not fulfilling it and the inventory doesn't. So that will bring to a stock out. And this will again be a continuous process that this supply demand balancing will actually run. We want to go into more SOMP together with IPP and others. We want to actually be part of a bigger SOMP process. And finally, we want to do a planning agent, which means with a lot of the insights that we will do in the first is we will come and tell you where the detection of issues is in your plans based on different time series analytics, like shortages and so on, and accuracy problems between your actual sales and your forecast. Because if we actually see that there's a big difference in your actual sales, we can predict that your forecast is not matching that trend that we have seen in your actual sales. And we can even detect how much the accuracy is off. And we can then suggest you to change your demand plan and actually run a new supply plan. Because if we will continue with this trend up, you will run out of stock simply and cannot fulfill the demand. So we will work on more planning agent where the system itself on the thing that we can detect can also suggest the solutions and potentially do the changes automatically. So this is a little bit about the roadmap. And again, there's no specific, I've mentioned what we're working on right now, and some of these we are working on. There's no deadline on when we will ship them in the product, but we are definitely working on some of these more advanced capabilities in the demand planning as well, plus Copilot. Here, I want to just tell you a little bit about some of the additional resources we have on top of this tech talk. So we have documentation in the SCM docs, where you normally find your docs about the whole SCM product. There is a whole section of demand planning. I encourage you to go and read the documentation. We keep updating that, of course, when we add new features. We have a very popular Yammer group that we're using. We try to be very active. We see very active customer and partners engagement there as well on a daily basis. So that's really great. We are also publishing surveys. We are publishing pictures and videos and so on, and also about news about what goes on in the demand planning if we are doing anything. We use both the Yammer group and also LinkedIn often to get and advertise for events. One other thing is there's also some hand-on labs. So we did a workshop in Denmark and in Redmond. Redmond, we did it in February. The hands-on labs that we did there, where we actually had customers and partners in for a 2-day workshop, these hands-on labs are available in the Yammer group. I just made them aware out in the right pane in the network resources, so it's much simpler to find these hands-on labs. But this is really step-by-step guides how to do different actions in the demand planning application. We have done a previous tech talk with some of my colleagues, Errol and Beatrice. I also encourage you to go and read that. That focus more on how you work in the worksheet, how you build a worksheet, how you can disaggregate and change the numbers in it. And finally, we also have tutorial and videos within the application and guided tours where you can also learn how to use the application.
Thank you very much, Anders. So now for the QA. So we have a lot of great questions. So starting out with one. So will the best fit model partition data according to dimensions? So if profit works better with some dimensions and agreement with others, will it both apply both appropriately? And so I will take this first one. The answer is yes. So the best fit will do the forecasting on an individual dimension combination basis, which means that if you have product A in warehouse 1, it may have a different characteristics than product A in warehouse 2. And therefore, it may be more appropriate to do a remount one, profit on another one, and it will select accordingly to the combination of dimensions in the time series. So the answer is yes here. And I'd like to combine that with one of the other questions. So best fit sounds like it'll handle all the rest for you. So why not just use that one? And so the answer is actually that is what we would like everyone to do. The idea here is that best fit should be doing a better job than the other forecast algorithms together, because it's simply combining the best of all worlds here. So the answer is please try it out and see the great results coming out of it. Then we have one regarding, can a normal SEO license holder approve, meaning publish is the last step, not an approval license. So what is needed for an approver? So Anders, would you like to take this one?
Okay, yeah. So if you come in with a standard license of SCM to the demand planning application, you can read worksheets, meaning the reports. You can see different combination of time series put together in a report. You can also then add a comment. That's the only thing you can do actively, rather than just reading data. You can create a comment, so you can mark a cell in a plan, in a time series, and say, I think this is the wrong number. That's the thing you can do. You cannot start editing the numbers. You cannot create new worksheets and stuff like that. You can only read stuff that is already there and make cell-level commenting.
So the next question, can we view the mate? So currently the calculated mate that was also called out by Mustafa is not visible directly in the system yet. We are working on getting that information into a view, so it's visible both in a view but also for some of the Copilot analysis. But basically today mate is not visible in the UI, but it will become in one of the later releases, where it's also going to be possible to see the selected algorithms per dimension combination, to make sure that there's transparency on what the algorithms have selected for it. So that is coming in a future release. Another question we have is, what F&O tables is historical demand data stored, and how does it hit that table? So is it at invoicing? And Anders, can you share a little bit about the historical data that we get from SCM?
Yes. So right now we are taking everything that gets, as soon as you do a packing slip update on a sales order. So we're reading the sales packing slip lines, and that's the one we're reading. That means that as soon as you do a packing slip update to a sales order, we're reading the sales packing slip line. And that means you have delivered the goods, and thereby you're fulfilling a demand. It also means that if you do a return, we will also get it as a negative demand. So we are actually already, and that means also we are not looking at inventories like other systems, well, in the past, you can argue, that because it also means that you can actually do selling of services, and we will all see it. So if you have an item that you're selling and it's type of service, not an inventory stock item, it will also be part of demand planning. And you can also plan selling services to machinery and stuff like that, which is a physical item that you may produce and sell. So if you sell service hours, that's actually also part of demand planning. Plus the return orders is part. So again, if you, let's say retail, and you actually sell a lot of stuff up to Christmas, and you know that a lot of people are actually returning it in January, we will actually know that and can actually forecast that you will have a lot of sales up to Christmas, seasonality-wise, and also that you expect to get a lot of the stuff back again in January. So you don't actually have to buy more stuff for January, because we already know that that demand will be covered by what is getting returned and so on. So because we're using the sales data rather than inventory data, we will actually also have more item types to cover. Plus we have better insights to returns and stuff like that as well.
Perfect. Thank you very much, Anders. We have one also on how does this solution compare to the previous capability called demand forecasting? Anders, would you like to call out a few words on this?
Yes. So some of the few ones here, and there's a lot, so it's a little bit much to cover, but I will do it very quickly. We can do holistic planning across your legal entities. So if you are an enterprise that has multiple legal entities, you can do holistic planning. So that means all planners have one source of truth for entire planning within the planning application. And you take decisions on changing your plans on a holistic planning. And then when we go for supply planning and put the data back again, we put it into the right companies and the right forecast models so you can run your right MRP in each company. But it still means you do holistic planning, which has been a request we have had for a long time. On top of that, we can actually also work across different ERP systems, which many of our customers have. So they can actually take data and again, build the holistic planning across multiple instances of FNO, but also they may have AX2012 in some regions still because they're only partly migrated, or they may have completely third-party ERP systems. We are then the system offering the holistic planning and the algorithms to do that. And when you get to the algorithms, running now the forecast with this algorithm, we are trying to democratize the use. They are free of charge. So they are part of the license that you're paying, free use of the AI models that we have. We do offer ability to use our whole app and collaborative planning with the cell level commenting, the versions, the team's capabilities of actually communicating in teams on a specific plan and all of that. If you actually still want to use Azure Machine Learning, and if you see that having your own forecast model as a competitive advantage, you can continue using that investment you did in the demand planning application, because you can call that out and use that model and get the data back in, and then you can still use our collaborative planning and with our role level security and our phase in and phase out and all of that, which is new that you didn't have. So that's why there is a lot of things that you get better. The UI is much quicker and faster to work with, and you can resize the dimensions, aggregate up, disaggregate up in a few seconds. That's why I'm saying there's many things that is much better in the new demand planning compared to the demand forecasting.
Thank you very much, Anders. So I think one final quick question for roadmap consideration. So will there be collaboration improvements on modifying forecasts to show what manual updates have been done to the generated forecast so that the changes can be seen by others? So for this particular one, you can actually go to the version history on the time series view, There you will be seeing which fields have been updated manually since the last run of the forecast or its last version of the forecast. So it should be visible already today, partially. Currently, you cannot see the values that have been selected, but you can see the person that had changed it, and you can see the actual cells or the dimension combination in time buckets that have been changed. So just a few comments on that one as well.
And I just want to make an add there, Peter. You can actually also, in the views, you can add the baseline forecast calculation and the current version that you're on, and then you can compare them. And then you can see total changes, and you can also see it in the grid, these two different versions of the same plan. And thereby you can see how much has changed. You cannot see who did it, but then you can see the net change that has happened between the current version of the plan and what the baseline forecast calculation was.
Perfect, Anders. Thank you for calling that one out. Thank you so much. So this concludes today's Tech Talk event. Thank you for attending.